welcome to the debate. Right now, there are, Fortune 500 companies spending millions of dollars on AI supercomputing just to do, essentially, the digital equivalent of calculating a restaurant tip. The era of writing a blank check for artificial intelligence is officially dead.
It had to die. I mean, that unconstrained, hype-driven capital allocation, where companies funded endless AI proof of concepts just to avoid the strategic fear of missing out, that's over. Being rapidly replaced by rigorous unit economic scrutiny and, frankly, strict return on investment validation.
Which brings us to the core tension we're analyzing today, directly from the latest source material on the new AI model war and enterprise spending reviews. We're asking a pretty fundamental question here.
Right.
Can the rapid, explosive technical innovations in AI architecture actually justify the massive operational costs? Or does the raw financial reality of enterprise deployment render current AI investments, structurally unsustainable?
It is the ultimate collision between computer science and corporate.
Exactly. And I will be arguing from the side of technical efficiency. My position is that cutting-edge architectural shifts like new reasoning paradigms, hardware optimizations, and incredibly efficient training methods, they are actively solving these cost bottlenecks. The technology is adapting, to ensure long-term economic viability.
And I'll be looking at this strictly through the lens of a financial executive, evaluating operational costs. From that perspective, I will argue that the hidden operational overhead paired with a severe mismatch between model capabilities and routine enterprise tasks makes the current total cost of ownership, or TCO, structurally ruinous. No matter how elegant the underlying code is, the math simply does not work for the modern enterprise.
Let's start with where the technology is right now. Because the AI industry they've fundamentally pivoted. We've moved away from the initial brute force race for raw parameter scale. Early on, developers just threw massive amounts of GPUs at massive data sets, creating these monolithic, incredibly compute-heavy foundational models.
Which was economically just completely untenable for production-grade enterprise infrastructure.
Right, which is exactly why we are now in a highly sophisticated war over inference efficiency. Developers are fundamentally reshaping how models operate. Take a sparse mixture of experts, or MO. We aren't activating multi-hundred billion parameters for every single word anymore.
Because doing that would bankrupt a company in API fees by Tuesday.
Precisely. But let's break down how Mo actually solves this. Think of an MOE model not like a single massive supercomputer, but like a massive research hospital.
Okay.
You don't make a patient see every single doctor in the building, right? You have a triage desk, a learned routing layer that directs the patient strictly to the cardiologist.
So you maintain the total knowledge capacity of the entire hospital.
Yes.
But you aren't paying for every doctor on every visit.
Exactly. Yes. You are only paying the active compute cost, the salary, so to speak, of the specific specialized subnetworks required to answer the prompt. It drastically reduces the active compute per token. And on top of that, we're seeing the rise of hybrid state space models, or SSMs, like Mamba and RWKVK, which, they solve the dreaded context window bottleneck.
The quadratic computational complexity problem.
Right. To explain that mechanically, traditional transformer models have a quadratic memory problem because they have to constantly look backward. If you feed a transformer a 100-page document by page 100, it is actively, mathematically comparing every new word to every single word on pages 1 through 99.
Which is incredibly inefficient.
The compute cost explodes exponentially, but SSMs process context in linear time.
Because they aren't looking backwards at every single token.
Right, they use a fixed size state tracking mechanism. It acts like a rolling summary that simply updates as it reads new information. The math stays flat, meaning you can process enormous enterprise documents without crashing your GPU cluster. These are paradigm shifts, making powerful AI financially.
I'm sorry, but let me tell you why. While those algorithmic optimizations, the MOEs and the SSMs, They are undeniably fascinating in a theoretical computer science paper. The financial reality on the ground is grim.
But
No, hear me out. The CFO isn't looking at linear time processing. They are looking at an unsustainable total cost of ownership.
I see why you think that, but isn't slashing the raw compute required to run inference directly addressing the TCO?
It addresses a fraction of it. Your entire argument rests on the assumption that the cost of AI is just the cost of model inference. You're hyper-focused on the algorithmic compute required to generate a token, while frankly completely ignoring the massive hidden engineering overhead required to actually make that token useful in a corporate setting.
Wait, let me stop you there. When you talk about this hidden engineering overhead, specifically things like maintaining retrieval augmented generation or RAG pipelines, I get the theory, but I'm slightly confused about the actual scale here. Is building a vector database really costing an enterprise more than the raw compute of continuously hitting a frontier model's API?
Oh, unequivocally yes. When you factor in the human capital, absolutely. The real cost isn't just the model execution. To make an AI model useful, it needs your proprietary company data.
Sure.
That means enterprises have to build low latency vector indexes. They have to continuously run computational pipelines to chunk and embed company data into vectors every single time a document is updated.
And you're saying the maintenance of that data pipeline outstrips the AI inference costs?
Easily, because you need dedicated, highly paid data engineers to maintain it. And that's before we even talk about custom guardrail integration. If you are a financial services firm, you have to build deterministic software layers around the AI so it doesn't, hallucinate a legally binding promise to a client.
Right, you need safeguards.
Exactly. You have to integrate these probabilistic AI pipelines with legacy deterministic enterprise resource planning or ERP systems.
But that is standard software integration.
It is extraordinarily expensive software integration. You talked about massive context windows as a technical triumph earlier, but in practice, shoving massive amounts of data into a prompt leads to context window bloat, the models lose the thread, latency spikes, and the system hallucinates. Suddenly, all those expected productivity gains are completely wiped out because you now need a human in the loop to manually verify the AI's output. The return on investment completely vanishes.
I hear you on the friction of integrating new technology with legacy systems. I really do. But I think you're treating enterprise integration as a static problem. The ecosystem is rapidly iterating past those friction points, especially at the hardware-software boundary. You brought up latency spikes and the cost of cloud infrastructure, which is exactly why the industry is pushing memory optimization techniques, like grouped query attention and multi-head latent attention.
Which essentially shrinks the memory footprint of the model while it's generating text.
Yes, it compresses the key value cache, the model's short-term memory, so you need fewer GPUs just to hold the model active. But even more critically, let's look at the breakthroughs in ultra-low-bit quantization, specifically FP4 and INT4 precision formats.
You're talking about compressing the mathematical weights of the model itself?
Exactly. We are taking massive floating point numbers and compressing them into highly efficient 4-bit integers. We are compressing the math so aggressively that multi-billion parameter models can now run locally on standard consumer hardware and local enterprise servers without any significant loss in downstream performance.
But how does running a quantized model locally solve the integration overhead I just mentioned?
By running these models locally, you completely bypass the ruinous API token tariffs. You directly slash the cloud infrastructure dependency, you eliminate the network latency spikes, and, crucially, you instantly solve the data privacy and compliance guarantees that highly regulated enterprise sectors demand.
Right, because it stays in-house.
Yes, you don't need a sprawling security apparatus if the data never leaves the building. The technology is actively adapting to the budget constraints.
That's a compelling argument, but have you considered that corporate procurement departments are already bypassing this entirely by just rejecting the models themselves? Let's look at multi-tiered inference routing, which the source material highlights as a major trend right now.
You mean dynamically routing different tasks to different sized models?
Yes. Organizations are being forced to shunt high-volume tasks away from those frontier models and down to highly constrained small language models, or SLMs. This isn't a technical triumph, it is an act of financial desperation. corporate procurement is actively rejecting unpredictable, consumption-based token billing. They are terrified of it.
Because they can't budget for a system where a busy month means the software bill quadruples.
Exactly. They want SaaS providers with clear outcome-based fixed pricing. The massive frontier models are simply too expensive for routine operations, so enterprises are frantically building these complex routing layers just to keep queries away from the expensive models to survive the economics.
That's an interesting point, though. I would frame it differently. This shift toward multi-tiered routing is actually a massive technical success, not a financial retreat. It represents the maturation of the ecosystem into multi-agent orchestration. It proves the technology is sophisticated enough to dynamically assess workload complexity.
But it introduces incredible complexity to the software stack.
It introduces proper resource allocation. We don't use a sledgehammer to drive a thumbtack, right? You route the high-volume deterministic tasks like basic document formatting or structured data extraction to a lightning-fast, ultra-cheap small language model, and you reserve the expensive closed-source frontier models strictly for advanced, multi-step logic.
But what justifies the massive cost of that frontier model, even for the advanced logic? I mean, the math still has to work for the CFO.
The new post-training reasoning paradigms justify it. We're moving beyond standard auto-regressive next token prediction, where the model just guesses the next most likely word. The new frontier models use test-time compute scaling.
Meaning they spend more computing power thinking before they actually start generating the answer.
Yes, through mechanisms like Monte Carlo tree search and tree of thought integration. Let me break that down. Instead of just answering a complex coding problem linearly and hoping it's right, the model internally maps out multiple different logical paths, a tree of thought.
Okay.
It generates a step, evaluates its own logic, kills the branches that lead to errors, and iterates until it finds the mathematically proven correct path.
It performs internal chain of thought verification.
Exactly. It dynamically allocates internal compute based on the complexity of your prompt to solve high-value software engineering and mathematical problems flawlessly. That is why you pay the premium. The SLM handles the volume, the reasoning model handles the heavy logic. That is architecturally brilliant.
Brilliant in a laboratory, yes. But in an enterprise, you are describing a level of architectural complexity that most IT departments are simply not equipped to manage. You're talking about maintaining multi-agent orchestrations, dynamic compute allocations, fleets of open-weight micromodels, and closed-source reasoning engines all talking to each other.
It requires disciplined systems engineering, certainly.
And disciplined systems engineering costs an absolute fortune. It requires highly specialized talent that commands a massive premium. Furthermore, the more you fragment the workload across this multi-tiered routing system, the more you are just building a multi-layered, fragile Rube Goldberg.
I think you're overstating the
Look, if an enterprise directs a query to a cheap SLM to save money, and that SLM fails to correctly extract a crucial numerical value from an invoice, and that error cascades into the company's legacy ERP system, the financial penalty of that hallucination far outweighs the fractions of a cent you saved on APIs.
Which is why evaluation and fine-tuning are so critical.
But enterprises don't want to be in the business of fine-tuning micro models and optimizing Monte Carlo tree searches. They want to buy a solution that works out of the box for a fixed quarterly. These frontier models with internal chain of thought verification are remarkable. But right now, they're essentially R&D projects funded by venture capital, subsidized by the cloud providers, and pushed onto enterprises that are realizing they don't actually need them for 90% of their workflows.
I'm not convinced by that line of reasoning, mostly because you are vastly underestimating how rapidly the barrier to entry for custom domain adaptation is dropping. You mentioned the cost of fine-tuning and getting models to accurately extract data without cascading errors. The long-term TCO is going to definitively drop because of a fundamental shift in how we generate training data.
You are referring to synthetic data factories.
I am. Historically, the massive operational bottleneck was human-generated data. Paying domain experts, lawyers, doctors, senior coders, to sit and label data for fine-tuning is incredibly slow and astronomically expensive. But developers have solved this. They're using specialized verifier models and automated theorem provers to generate, critique, and filter dense, error-free reasoning datasets at a massive scale.
They are using AI to create the data to train the next AI.
Yes, bypassing the human data bottleneck entirely. And when you pair that flawless synthetic data with parameter-efficient fine-tuning methodologies, specifically techniques like LoRa and QLoRa, the enterprise economics change overnight.
Sure, you're only updating a fraction of the weights, which saves massive compute. But that still doesn't solve the absolute need for vendor neutrality and manageable infrastructure.
Let's explain why LoRa matters so much to the CFO, though. Normally, fine-tuning a model means retraining massive, dense weight matrices. You are effectively unfreezing the entire brain of the AI and recalculating billions of parameters. It costs a fortune in GPU time. But LoRa, low-rank adaptation, freezes the main brain of the model. It injects a tiny, highly compressed matrix. Think of it like sliding a sticky note into a textbook.
You update the sticky note, not the textbook.
Exactly. The enterprise can adapt a highly capable model to its specific domain by just training that tiny sticky note. The compute cost drops by orders of magnitude. You don't need a team of expensive machine learning researchers. An enterprise can efficiently adapt an open weight model to perfectly execute their specific operational workflows. This directly attacks that operational overhead you were so worried about.
That is a highly elegant technical solution. But again, let's look at this through the CFO's perspective. Synthetic data factories and LoRa sticky notes might radically lower the compute cost for the developers, but unless those savings translate to predictable, capped operational costs at the enterprise layer, the balance sheet remains unmanageable.
But they do translate. Local execution of adapted models inherently caps costs.
Only if the implementation is flawless. The market transition we're seeing from speculative hype into disciplined systems engineering proves that theoretical algorithmic accuracy is no longer the primary metric of success. The source material is very clear on this. The winners in this AI model war won't just be the labs that generate the best synthetic data or achieve the highest scores on theoretical math benchmarks.
Who will the winners be then, from the financial perspective?
The winners will be the platforms that can offer absolute vendor neutrality and viable hybrid edge-to-cloud strategies. Enterprises are terrified of vendor lock-in. If you build your entire automated workflow around a proprietary API, that provider can arbitrarily raise their consumption fees next year, and you have zero leverage.
Which loops back to the importance of the open weight models we discussed.
Yes, but it requires strict financial governance. Enterprises are establishing hard cost per query caps. They are enforcing strict key performance indicators for these automation tools. They are forcing the AI industry to bend to corporate financial reality. A model has to prove its worth on a quarterly balance sheet, not just in a research paper outlining linear time context. Until the hidden operational overhead of data hygiene, vector maintenance, and legacy integrations are fully commoditized, strict ROI validation will trump raw technical capabilities every single time.
You know, I think this is actually where our perspectives completely converge.
Really?
Yeah. We are analyzing the exact same industry transition just from different ends of the telescope. I am pointing out that the era of unconstrained AI experimentation is dead because the technology has evolved. Through quantization, sparse mixture of experts, and agentic frameworks, the engineers are aggressively driving down the computational cost of intelligence to build a resilient, efficient foundation.
And I am pointing out that the era of unconstrained experimentation is dead because the corporate finance teams finally audited the service bills. The industry permanently shifted toward economic feasibility out of absolute necessity. If the AI doesn't generate measurable, verifiable operational efficiency that exceeds its infrastructure costs, the CFO kills the project.
Exactly. The sophistication of the technology and the strictness of the corporate budget are actively forcing each other to adapt. The technical innovations, the sub-second latency micromodels, the ultra-low bit precision formats, they are successfully driving down the total cost of ownership. They are making it possible for organizations to refactor their software stacks without bankrupting themselves.
While simultaneously, those financial realities, the cost per query caps, the outright rejection of unpredictable token billing, are acting as a forcing function. They are ensuring that AI development remains strictly tethered to actual business utility, rather than just chasing theoretical intelligence benchmarks.
It really highlights the immense value of analyzing this shift through multiple disciplines. You simply cannot understand the trajectory of AI right now by only looking at the computer science algorithms, and you can't understand it by only looking at the corporate balance sheets.
Complexity absolutely requires multiple perspectives. The transition we are going to see over the next decade, from monolithic foundational models to sprawling networks of specialized, highly efficient agents, is going to completely redefine enterprise architecture.
And for those listening, there is so much more depth to explore in the source material regarding exactly how these specialized micromodels will operate under future agentic frameworks, and how edge execution on local hardware is going to fundamentally change the economics of enterprise software.
It is going to be a fascinating evolution to watch. The AI industry is currently racing to build a sustainable financial model before the enterprise sector decides the fuel is just too expensive to keep driving.
We will leave it to the listener to form their own conclusion on whether the blistering pace of technical efficiency will ultimately outpace the rigid financial realities of corporate integration. Thank you for joining us on The Debate.